So for those of you who don't know my company, I'm founder and CEO of SOLS. We're a company focused on building the future of movement and doing that through mass customized footwear. Our first product is a 3D printed orthotic, which we're shipping now through hundreds of doctors and to thousands of customers. Just launched a pop-up shop on the Bowery, and incredibly excited about how we can build scalable platforms for mass customization that make this world of a truly customized future with 3D printing possible. So before we kick into the more technical aspects, I thought I would show you a video just sort of giving you an overarching view of our platform and our technology. When I started SOLS, the key differentiating factor between what we were doing and what I saw other people in the 3D printing and mass customized space doing was looking at it from a systematic perspective. It wasn't about how do we take a Connect sensor or how do we take off-the-shelf scanning technology, or how do I get somebody to go to Best Buy and put something on an iPad. It was about how do I take technology that is in everybody's phone, how do I take an iPhone, how do I take an Android, how do I use that and enable the customer with that technology to customize themselves. And when I first started with that idea and I went out to raise our first round of financing, the investors, they looked at me and they thought I was crazy. They said, hey, why don't you, there's a million different off-the-shelf opportunities out there. You're going into the medical space. You could easily just ship all these doctors a scanner. You could let them use their existing scanning technology. But for me, for this world to make sense, for mass customization to be possible, it had to happen on that existing device. And that's what we've done here at SOLS.
Life starts from the ground up. Our feet determine how we stand, how we move, and where we go. From uptown to downtown, from city to suburbs, from dirt trail to dance floor. Every path, every story is different, and so is every foot. That's why SOLS envisions a future of footwear that is not only custom-made for your body and your lifestyle, but also custom-made for your every movement. Today, SOLS has integrated next-generation computer vision and 3D printing technology to create a customized insert that is perfectly sculpted to support you and correct your biomechanical alignment. The SOLS digital fitting process is data-driven, repeatable, and accurate. It starts by capturing 3 images of the foot. Our computer algorithm then extracts key data points from these images to generate a completely custom 3D model of the orthotic, which is further customized to fit the features a provider prescribes to account for any biomechanical misalignments. Finally, SOLS uses 3D printing with NASA-grade nylon 11 material to turn these models into a reality. SOLS takes a holistic approach to foot health and promotes overall well-being from the ground up. Walk farther, run faster, dance longer, jump higher, be unstoppable.
Thanks, everyone. So going back to what I was saying earlier, what we do is something that I refer to as product as process. We develop systems. Those systems enable scalable mass customization. What that looks like from a technical perspective is that we have an iPhone. We enable our doctors with iPhones. Soon we'll enable consumers with iPhones to take 3 photos of the foot. They take a photo of the inside, the arch view, of the back of the ankle, and of the plantar surface of the foot. We then use those photos. We extract a series of data points. We plug them into a script. We use that script to generate an STL file, and that STL file goes down to production at our factory in Texas. It gets shipped back up to us, and then ultimately it goes to the consumer. In practice, while obviously, when you look at these things, you're like, okay, we're building an automated, scalable system for mass customization. Obviously, there's a huge amount of challenges behind that I don't think that I could have imagined that we would have run into when starting the company. It's very easy to say, okay, we're going to take iPhones and we're going to use iPhones to make customized orthotics. It's a whole nother thing to look at some of the real world challenges that happen and that occur when you are actually trying to take technology, you're trying to make it invisible, and you're ultimately using it to create a product that to the consumer is just meant to make their lives better. Most of our consumers don't even know that soles are 3D printed. To them, it's an orthotic that they got from their podiatrist that is hopefully much better than anything else that they would have gotten otherwise. So it all starts with something that we call SALI. SALI is basically leveraging semantic segmentation to analyze these photos. We're breaking the images apart when we're saying, okay, how can we identify the foot in the series of photos? We have a team of trainers on site that are effectively processing images and allowing us to get smarter and smarter and smarter with each pair of soles that we ship. The cool thing is that with that, it means that our algorithms are constantly improving. It means as we ship more and more product into the world, our product gets better, it gets more refined, there's more data behind it, and ultimately soles improve. Now, obviously, some of the real-world problems that we've run into, we encounter blurry photos, we encounter reflectivity. We see that humans and doctors can't take photos. That even with the help in the iPad app that we give them, where we're using the accelerometer to help them hold the iPad level, to help them take photos in the appropriate lighting conditions. Soon, we'll actually be doing on-the-fly detection of photo quality to help them improve it further. There are so many challenges. Even something as slight as somebody tipping their foot in like slightly the wrong direction, or having their ankle collapse in the wrong way. I mean, we're looking at fleshy-bodied objects in photos, and we're using that to derive a physical hard-bodied form. And the multitude of challenges that come with that are extremely complex. So because of that, what happens is we have the next stage of our process. So we start with these photos, we extract the data points, we say, okay, this is what we think the foot looks like. And then we say, okay, based upon known factors, based upon this probabilistic model that we've made, and we take a statistical approach to that, and we say, how do we then edit these data points? How do we take what we know quantitatively about the individual and apply that and combine it with what we know qualitatively about them? Qualitative fit is something that's really, really interesting. I don't think that I ever could have imagined that it would have been so challenging and it would have had such an impact. You know, we think about customization, and we want to apply this technical approach to it, and we want to say, okay, well, I have my body, I scan my body, I make something that's perfect for me, and yet what we find is that people like different things. Some people like their soles to fit looser. Some people like them to be tighter. Some people wear shoes that are 2 sizes too small. Other people wear them that are 2 sizes too big. Other ones wear them with really, really pointy toe boxes, or want to be able to wiggle their toes in a way that maybe like a runner or an athlete has an entirely different perspective on. And so we've worked hard to apply both the quantitative and the qualitative aspects to this step in the process. It's as much about knowing what somebody's biomechanics is like as it is about knowing how much they weigh, what they're going to wear the soles for, what kind of shoes that they're going to wear them in, what kind of footwear they've previously worn. And taking all of that and combining it into the algorithm to get the fit right. Does that mean we get it right every time? No. Right now, I think we're averaging, let's call it 92% first time right for custom fit, which in my understanding is pretty great. You know, I would love, obviously, to be at a higher point than that. But the fact that we're shipping, 90% of soles that are great based upon a series of 6 photos that somebody's taking out the gate, I think is pretty exciting. And finally, it's about looking at that and saying, okay, it's not just about the physical, or it's not just about the digital input and taking that and putting it into our model, but it's about actually closing that loop and saying, how can we take a real-time approach to product development? How can we then take the data that we get back from the customers, analyze that data, and say, okay, so we shipped a pair of soles. Is it good? Yes, check. Okay, so we know this worked for this demographic, for this age group, for this weight class. Is it not right? Okay, well, how do we need to change it to make it right? Are all feet the same? Do we need to adjust our algorithm to account for more and more variability? And as we grow as a company, and as we ship more soles, and we encounter more feet types, and frankly, our database of feet gets bigger, we begin to make it more and more complex in this way, and we begin to constantly feed that data and feed that input back into our model so that it can learn, so that it can grow. A great example of this is, I think last week or the week before, we pushed out a fix that was accounting for 80% of the remakes which we were encountering, which dealt with how we defined the toe box shape. And it was as simple as looking at the model and saying, okay, mapping back this section of complaints that we were getting to this portion of the model, pushing that out, and then seeing the immediate impact. The great thing about 3D printing, the great thing about digital manufacturing is the fact that you truly are developing products in real time. This isn't about like looking at what the market wants, let's say, in a year from now, predicting what the market market wants and then making a product that's going to serve that. It's about saying, what does the market want tomorrow? What are we shipping today? What are our doctors saying tomorrow? And then feeding that back so that our product is constantly getting better, so the moat between us and our competitors is constantly getting wider. And ultimately, we continue to position ourselves as the market leader in mass customization and 3D printing. And what you see here, and I know I'm out of time, but really quickly, what you see here is effectively what that model looks like, where we're training these algorithms. We're using machine learning to apply that data that we're receiving back from our customers to the model so that it improves constantly. We're using that to generate 3D files. The way that we've designed that is pretty cool in that we're enabling our biomechanical engineers to work in their language, which is math, and we're combining that with our software engineers so that we're actually plugging those equations into code and enabling the biomechanics people to design and code without actually having to know how to write the scripts. And it enables us to work much, much faster than we have been able to in the past, and really put out real-time product, creating an entirely new language and an entirely new framework around it. And finally, obviously, pushing those products out into the world, capturing that human feedback, trying to close that loop between where the moment where that product ends up on the user's foot, where we're capturing that data, where we're capturing that feedback from them, doing an analysis on that. Right now, a lot of that's happening manually, but we do hope that will happen through machine learning in the future, and then pushing that back, starting again, going back to training, and we repeat this cycle almost on a daily basis. So finally, what does that lead to? What are we doing? We're building products that adapt to us. We're building a foundation. We're building software. We're building a platform that enables products that adapt to us. Today we make soles, but I could plug any kind of product I wanted to in our platform. It could be braces. It could be casts. It could be helmets. It could be shoulder pads. Literally, if I wanted to change the company from an orthotics company to a footwear company to a helmet company to a bicycle seat company tomorrow, I could do that. And I think for that, that is what enables the future that we want to be possible. That's what enables mass customization to be possible. And then when you combine that with advanced data and you combine that with this idea of iterative real-time product development, you effectively have an entirely new kind of mass customization, a new kind of launching product into the world, and you move from a world where we have marketing-driven companies to a world where we have data-driven product companies. And I think we can all imagine what that looks like, where we are all truly enabled to be ourselves, to be individuals, and to have things which are uniquely designed for us. I hope that world starts with SOLS, and I'm excited to be pioneering some of the technology behind that. Thank you.
Fantastic, Kegan. Thank you very much.